Okay, so picture this. You're sitting down, maybe looking at quotes for a brand new turn mill center. Big investment. This machine, it's going to be the core of your shop for, what, the next 10 years maybe?
Easily, yeah.
And then you hit this line item on the spec sheet, turret system. And it just says VDI or BMT.
Just letters, cryptic, right? If you're not deep in machine specs daily.
Exactly. And, our sources are pretty clear on this. Getting this wrong isn't trivial. It could mean constant chatter, maybe not having enough power for a job, or just setups taking forever.
Yeah, it really defines what that machine is truly good at. It's fundamental.
So the decision, it seems to boil down to this. Do you need speed, flexibility, quick changes? Or is it about raw power, like sheer stability?
That's the core trade-off, absolutely. Speed versus strength in a way.
Okay, let's unpack this. We're aiming for a shortcut here. We want you to walk away knowing why BMT is the go-to for heavy milling and why VDI is still the champ when you need fast changeovers. Let's dig in.
Right. And to really get why they perform so differently.
Yeah.
The stability, the chatter, the speed, it all starts with how they physically mount to the turret. That's the fundamental difference.
The mechanics of it.
Exactly. Let's start with VDI. It's actually an acronym, Verein Deutscher Ingenieure. It's an older German standard.
Oh, okay.
And the design is, well, we sometimes call it the peg in a hole idea.
Peg in a hole, right.
You've got a tool holder with this single shaft. It's usually serrated, and that slides into a precision bore on the turret body.
And the serrations stop it twisting?
Precisely. Stops rotation. Then there's just one clamping mechanism. It could be a bolt, maybe a wedge system that pulls it tight.
Simple. Sounds fast.
It is simple, and it can be fast.
Yeah.
But structurally, that single point of contact concentrated around the shaft, well, that's where its limits show up when you really start pushing things.
And the sources mentioned a specific setup hassle there, too, because it's just that shaft and a bore. Alignment isn't guaranteed, is it? Which means indicating.
You got it. That's the kicker with VDI. It often usually needs the operator to manually indicate the tool holder.
With a dial indicator.
Yep. Run a dial indicator across it to make absolutely sure it's sitting perfectly straight before you fully lock it down.
Yeah.
If you skip that or rush it,
you get taper or run out on the fade.
Exactly. And that manual step, it adds minutes every single time you change a tool.
So if VDI is maybe structurally not as strong and it needs this kind of fiddly indicating step, why is it still around? I mean, what's the advantage of that single shaft besides maybe just speed?
Well, cost is a big one, which we'll get to. Simplicity helps there. But first, let's contrast it with BMT, base mount tooling.
Okay.
Structurally, it's the complete opposite philosophy. Think of it like bolting a solid block of steel directly onto another solid block.
So face-to-face contact.
Exactly. The BMT holder mounts directly against the flat face of the turret itself.
Hello.
And is secured not by one clamp, but by 4 heavy-duty screws.
Okay, just hearing that 4 bolts, big flat face, it sounds way more rigid. But what about alignment? Do you still need to indicate BMT?
Nope. And that's the beauty of it for accuracy. BMT uses solid locating keys, think precision dowels, really that fit into matching slots machined right into the turret face.
Oh, so they positively locate it?
Right. When the operator tightens those 4 bolts, the holder's automatically pulled into perfect alignment every time. No indicating needed. It's that large face-to-face contact locked down at 4 points. That's the source of its strength.
Okay, so let me try and summarize that mechanical bit for everyone listening.
Yeah.
VDI. Single shaft, slips in, single clamp, needs manual checking for alignment, less contact area. BMT, bolts flat onto the face, uses 4 screws, has locating keys for automatic alignment, huge contact area, maximum stability.
And that's a perfect summary. Captures the core difference.
Right. All right, so we get the how. Now let's talk why. Heavy machining. This is where things get serious, right? Where profits on tough jobs are made or lost. And BMT is called the champ here. Why? Where does that power really come from?
It's all about rigidity. Simple as that. That 4-bolt face mount design. It essentially makes the tool holder and the turret one solid piece of metal.
Like they're fused together almost.
Almost, yeah. It creates this incredibly stiff assembly that just resists deflection and absorbs vibration way better. Especially important for radial forces in milling or axial forces in drilling.
The sources had a great example, the classic pain point.
Yeah.
Interrupted cuts. Every machinist hates those.
Oh, yeah. It's the ultimate test for rigidity, isn't it? Imagine you're turning a big, heavy casting. Maybe it's got holes or gaps in it.
So the tool's cutting metal, then air, and slams back into metal.
Exactly. It's like hitting the tool holder with a hammer every single revolution. The source described this exact scenario on a VDI machine. Sounded awful. like a jackhammer, constant chatter, terrible finish, and breaking inserts like crazy.
Expensive inserts, too.
Oh, absolutely. 3 an hour, the source said. Then they took the exact same tooling, same program, put it on an identical machine, but with a BMT turret. Just ate the job. Smooth, quiet cutting. The BMT system just soaked up those impacts. No chatter, great finish, and the tool life went way, way up.
And that rigidity, preventing the vibration and deflection, that directly hits the bottom line, doesn't it? You can push harder, higher feed rates, maybe?
Definitely higher feeds and speeds are possible. Plus, your tools last longer, which cuts costs significantly. It all adds up to higher productivity.
So better parts, faster cycles, cheaper tooling costs in the long run.
Precisely. So if you're a shop dealing with tough materials, think Incanal, titanium, maybe some hardened steels, or doing a lot of heavy milling, deep drilling, BMT is often the smarter, safer bet. It protects the machine's live tooling drive, protects your expensive cutters, because less energy goes into shaking and vibration.
Okay, that makes sense. But isn't there a catch with that perfect flat face mounting on BMT? What about chips? If even one tiny chip gets stuck between the holder and the turret face when you change tools, doesn't that throw the alignment right off?
That is absolutely the trade-off. Great point. BMT demands cleanliness, discipline from the operator.
Right.
Because its accuracy depends entirely on that perfect face-to-face contact. Get a chip in there, you instantly introduce runout. You could even damage the locating keys or score the turret face if you tighten it down hard.
Whereas VDI, with just the shaft and the bore, it's probably more forgiving if things aren't perfectly clean.
Much more forgiving, yeah. A chip in the bore might cause slight misalignment you'd catch during indicating, but it's less likely to cause actual damage. BMT needs that surface wiped clean every single time.
Okay, good practical point. Now, let's shift gears. Forget the super alloys for a second. Think about like a prototype shop or a job shop doing, 20 different setups a day.
High mix, low volume.
For them, setup time is everything, right? Machine utilization is king, BMT stability is awesome, but undoing 4 bolts every time, that sounds slow.
It is slower.
Yeah.
Significantly slower. And this is exactly where VDI flips the script and becomes the champion.
Speed and agility.
Absolutely. In those high-mix, low-volume places, maybe you're only making 10 parts, 20 parts, then you're tearing down for the next job. You spend way more time setting up than actually cutting metal sometimes.
Makes sense.
And this is where that simple single-clamp VDI design really pays off. Think about the actual time saved. Let's say an operator changes tools, 20 times in a shift on a BMT machine.
Okay.
That's 80 screws they have to handle. Unscrew, clean the interface, position the new tool, screw them back in, torque them down.
80 times versus VDI.
VDI, pop the wedge or loosen the bolt, pull the tool out, slide the new one in, tighten the wedge or bolt, done, ready to indicate.
And the sources suggested a skilled operator could do that VDI swap itself in, under 30 seconds before indicating.
Easily. The swap is incredibly fast. So even if you add a minute for careful indicating, you're still way ahead.
And that time difference adds up fast.
Hugely. If a BMT change takes, say, 3 to 5 minutes all in, and VDI takes maybe a minute total, including indicating, you're saving several minutes per change. Multiply that by dozens of changes a day across multiple machines.
You're actually freeing up significant spindle time.
Exactly. We're talking maybe increasing the machine's actual cutting time, its utilization, by 20%, maybe even 30% in a really dynamic job shop setting. That speed keeps the spindle turning. That's profit in those environments.
VDI also seems to have this built-in flexibility that BMT, just by how it mounts, can't really offer.
That's true too. Modularity is a big plus for VDI. Because it's based on that simple round shaft, you can easily find holders for both axial mounting, on the face, and radial mounting coming out the side. Gives you more options sometimes.
More ways to position the tool.
Right. And also, because the VDI holder itself is simpler, it's generally easier to preset offline on a tool presetter. Get the offsets dialed in while the machine is still running the previous job. That cuts down spindle idle time even more.
But, okay, let's bring it back to the limits. That speed, that flexibility, it comes at a price in terms of power, right?
Yeah.
Where does VDI just give up? When does it fail?
Oh, yeah. It has clear limits. If you need to take really heavy cuts, big depth of cut, high feed rates, especially with tools that stick out far from the turret, think long boring bars or heavy milling heads.
Leverage.
Exactly. That single shaft mounting just doesn't have the rigidity. It'll start to deflect. You'll get vibration, chatter.
It's physically not capable of handling the kind of forces that BMT's solid 4-bolt face connection can just absorb. VDI is built for speed and flexibility. BMT is built for power and stability.
Okay, let's talk dollars and cents then. The
Yeah.
practical side, cost, initial cost, ongoing cost.
Right.
VDI holders are cheaper. The sources say maybe 20% to even 50% less than a comparable BMT holder sometimes. Why such a big difference? It really comes down to manufacturing precision. VDI is, relatively speaking, a simpler component to make accurately.
The peg in a hole is less demanding.
Right, but BMT, that's a premium system. That mounting face has to be perfectly flat. The locating keyways need to be incredibly precise in size and position. The 4 bolt holes need perfect spacing. Any error there compromises the entire system's accuracy and rigidity.
So that high-precision machining just costs more.
A lot more, yeah. Requires better machines, more careful processes, tighter quality control. That adds significant cost.
And what about availability? Finding these holders when you need them? VDI seems like it would be everywhere, being an older standard.
It pretty much is. VDI is a global standard made by hundreds of companies. You'll basically never struggle to find a standard VDI holder anywhere in the world. And that competition keeps prices down too.
And BMT.
BMT has really strong adoption now, especially on higher performance machines, often from Japanese or European builders. All the major tooling suppliers stock it heavily. It's definitely readily available.
Okay.
But if you need something really unusual, a very specialized holder, the VDI market is just bigger, more options, probably cheaper options too.
But we always tell listeners, think total cost of ownership, right? Not just the sticker price of the holder. The sources made a good point. Saving money on a VDI holder up front doesn't help if you actually needed BMT's rigidity.
Couldn't agree more. That higher initial cost for BMT, think of it as an investment in stability and predictability. If your work involves those tough materials, those interrupted cuts.
Where you're breaking expensive inserts or scrapping parts due to chatter.
It's exactly. If you're fighting those problems with VDI, the money you saved on the holders gets wiped out incredibly fast. A BMT system can genuinely pay for itself within months, just in reduced tooling costs and less scrap on those demanding jobs. So if we connect this to the bigger picture, you really need to look hard at your typical workload. Not just today, but what you expect over the next, say, 3 to 5 years before you check that box on the machine spec.
Makes sense.
Choose VDI if your shop lives and dies by setup speed. If you run a huge mix of different jobs every day. If initial tooling cost is a major factor, and most of your work is, let's say, general turning and lighter cuts on common materials.
Speed, flexibility, lower initial costs.
Right. But choose BMT if you consistently deal with demanding work. Heavy milling, maybe deep drilling, definitely interrupting cuts. Or if you're machining tough alloys, aerospace materials, medical parts, choose BMT when stability is paramount, when you need predictable results, and when the cost of failure, especially a broken tool, a scrapped part, is really high.
Power, stability, tough materials.
That's the BMT world.
So what does this all mean for you, the listener, who might be signing that PO soon? The final thought we want to leave you with is this. Really focus on the biggest pain point in your current operation. Don't just get seduced by the specs on the new machine.
Good point. Look at your failures.
Yeah. Before you commit, ask yourself, where are we losing the most money or time right now? Is it because setups take too long? Are operators constantly fiddling with indicators, slowing down every changeover? If that's your bottleneck.
That points towards VDI speed.
Exactly. Or are you losing money because you're fighting chatter all the time, breaking expensive tools constantly, having to back off feeds and speeds just to get a decent part on those tough jobs?
That sounds like a cry for BMT's rigidity.
It does, right? So, which failure point, slow setups, or unstable cutting is truly the more expensive bottleneck for your specific shop? Answering that, honestly, should really guide your choice on that spec sheet.